This screencast is about using Excel. Future modules will require Excel skills. I brought up an Excel worksheet, set it up a little bit. Here are the 5 Store 1 cash register receipts, and just to the right of those are the 5 Store 2 cash register receipts. If we want to find the sum of the 5 Store 1 cash register receipts, we can simply highlight those receipts and go up here to AutoSum, click on it, and Excel places in the first available cell underneath the 5 cash register receipts the total or sum of the 5 cash register receipts. If we want to find the sum of the 5 Store 2 cash register receipts, and I'll do something just a little bit different just to show you how it works, I'm going to highlight this column, including the label in the top row, and when I press the AutoSum button, we still get the sum. Excel simply ignores the words in the label row and just sums the numbers. Next thing we want to do is compute the sample means. They're the sample averages, and place them here. So if we want to compute the sample mean of the Store 1 cash register receipts, we can highlight those again. Go back up here to the AutoSum feature, but now click on the arrow to get the drop-down box and then select Average. And Excel places in the first available cell under the cash register receipts, it places the average of the 5 cash register receipts. We didn't have the 400 highlighted, so that wasn't included in computing of this 80. And we can do the same thing for the Store 2 cash register receipts. We know we're going to use a grand mean. Let's compute it right now. The grand mean is simply the sum of all of the cash register receipts, both for Store 1 and Store 2, divided by the total number of cash register receipts, 10. Here's the sum of the Store 1 cash register receipts, and here's the sum of the Store 2 cash register receipts. So we simply have to add these two and then divide by 10. Let's do that. We'll do it with an Excel formula that we'll place in cell E7. Click on that cell. Always start a formula with an equal sign. Then we're going to say parents. I want to place this 400 in as a first entry, so I'll just click on that and Excel will say we're putting what you have in cell B7 in this position. Tell Excel I want to add to that what's over here in cell C7, and Excel will say okay, I'm doing that. And you do need the parentheses there. Divide it by the total number of cash register receipts in both samples, 10. And then if you just tab out of there, Excel computes the grand mean to be 90. Pretty straightforward. 400 and 500 is 900 divided by 10 is 90. So we've again seen that the sample 1 mean x1 bar is 80. The sample 2 mean x2 bar is 100, and the grand mean x double bar is 90. Let's now compute SSA. SSA has a component from the first sample, from the Store 1 cash register receipts, and a component from the Store 2 cash register receipts, the second sample. The total of those two components will give us SSA. The first component is the total number of observations, and we're going to have to use a formula for this, so let me start it with an equal sign. It's equals parents, the first sample mean, minus the grand mean, the quantity squared. Oh, and I forgot, that needs to be multiplied by, and I'll put it out front here, by the total number of observations in the first sample, 5, and multiplication is indicated in Excel with an asterisk. So this will give us the component of SSA that comes from the first sample. Now, if I would like, I could go back here. This will be a little harder to see. I could just drag this formula over and have it for here, except I need to freeze this particular entry, the entry in column E, row 7. When I move it one column to the right, if I don't freeze that E, then it will turn out to be an F when I drag it across. So I'm going to put a $ in front of the E just to make sure it'll be an E when I drag it to the next cell. There's the 500. So I'm going to drag it to the next cell, and I should get the 500. Now it's not the same 500, it's a different 500. As you'll see, it's the 5 observations in sample 2 times the entry in cell C8. C8 is the second sample mean, minus the, and I froze that E so it wouldn't go up to an F when I drag things to the right. In cell E7 is the grand mean, so that's correct, it's squared, and we still have that 5 out there. So now if I just sum these two, I'll get SSA, and that's relatively straightforward. I'm going to go over here and enter the formula equals what's here plus what's here. Tab out of that. The SSA total is 1,000 units. Now, if we didn't want to work in 1 decimal point, we could just, and I don't see any reason why not for these quantities, to just make them pure numbers without any decimal points. So let's go over here to number. I clicked on number up here. I came down here. I want to deal with a number. The default value here is 2 decimal places, but I want to just get rid of the decimal places in the columns that are highlighted here. So now I'm just going to have the 1,000. Okay, let's compute the SSW number. SSW, the actual number, will go over here. The 2 components, there's one from the store 1 cash register receipts and another component from the store 2 cash register receipts. Let's compute those. We'll need equations for that. The equations are, we're going to start with the first cash register receipt from store 1 minus the sample mean, the store 1 sample mean, and we want to square that because that's what the formula says. And then I'm going to add to that, well, what I'm going to add is the second store 1 cash register receipt minus the first sample mean, the quantity squared. But rather than typing it in, I'm kind of lazy here. I'm going to just see if I can get around typing it in by highlighting that and then clicking paste 4 times. I'm going to put in here, use B3, the 73. Here use B4. the 77. Here use B5, the 69, and here use B6, the 93. Now I don't need that last plus sign. I was getting that when I was pasting it in, so let me get rid of that. I don't think anything would have changed if I would have left it in there, but I didn't need it. Now if I tab out of there, we'll get the 412, and you might remember that as the SSW component that came from the store 1 cash register receipts. And now we want to compute the same thing for store 2. Now, if we simply drag this over here to store 2, we're going to have all the column references move one column to the right, and it'll compute the same thing in this column that it computed over in this column. So this should work for us. And of course it did. You see all of the B's there changed the C's when we moved it one column to the right. So now that's all that's left is to add the store 1 SSW component to the store 2 SSW component. And you know what? We should be able to do that by just, we can do it separately, but it's exactly the same thing as what we did here. So I could just drag that down and it'll just add these two quantities. So we've got the 728 SSW. You might remember we got 728 in the previous screencast, but I did change the color when I dragged it, I guess, and that's no big deal, but let me change it back to pink. Okay, MSA. MSA is simply SSA over C minus 1, where C is the number of populations, in this case the number of stores, same as the number of samples. 2 minus 1, that's just 1. So, well, it's silly to calculate this, but let's go ahead and do it anyhow. It's SSA divided by C minus 1, and in a general situation we'd need a parent there, divided by, in this case, 2 minus 1. And if we tab out of there, we'll just get 1,000 divided by 1,000. MSA in this case is the same as SSA. Now let's compute MSW. We compute MSW by taking SSW and dividing it by its degrees of freedom. And its degrees of freedom is n minus c. Total number of observations, n, is 10, minus the total number of stores we're dealing with, 2. 10 minus 2 is 8. So formula time equals SSW divided by, gee, it's silly to spell it out this way, but let's do it, n, 10, minus c, 2. Tab out of there. And we get MSW is 91. That was just 728 divided by 8. Now let's obtain the value of the F statistic. Remember, the F statistic is MSA divided by MSW. And for these sample observations, the F statistic computes out to be 1,000 over 91. Let's ask Excel to do that calculation for us. Equals 1,000 divided by 91. Tab out of there. 10.99. You know, I think we had that out to more decimal place accuracy before. 10.980, whatever it was. Let me go out to, we might have had it at 6 before, I'm not sure. 10.989011, I bet we had it at 5 before. None of this matters because Excel uses, when it makes calculations, the total amount of accuracy that's hidden in that cell that Excel can compute to. It doesn't just do the calculation to the number of decimal places that you've asked displayed.